Hello, and thank you for joining me for this final instalment of the Edexcel November 2018 Higher Tier GCSE Maths exams. This is the third of three for November 2018. In other words, we're talking about paper 3 today. It's a calculator paper, so if you're going through these solutions with me, please do make sure you've got a scientific calculator. By that, I don't mean a smartphone or some sort of app you've downloaded on your smartphone. So have a scientific calculator, use it, and know it well. So let's talk through each and every question in detail, starting of course, as ever, with question 1. Question 1, we need to round this number to 3 significant figures. Well, if we're rounding a number to 3 significant figures, we start counting from the first number that is not 0. So that's our first number, 7. So 1, 2, 3, there are our significant figures. So the 7 isn't the number we're going to count. So we need to round this 735. So, as ever, to see if this 5 is going to stay as a 5 or round up, we look at the number next door to it, which is a 7. 7's 5 or higher, which means this 5 is rounded up to a 6. So our answer to 3 sig figs is 7, 3, 6. First, second, third significant figure. However, when we round into significant figures, we need to make absolutely sure our answer is in the right order of magnitude. It has to be about the same size as the initial number. So here, this obviously is nowhere near as big. Where that's corrected is any numbers after what we've rounded to, so for example the 4th figure onwards, after the significant figures we've rounded to, we just change those into zeros. So this 7, just knock it to a 0. Another way we can think of rounding to significant figures is we have a look at the third significant figure, because it's 3 sig figs. So 3, think the third one. So that 5 is key. That 5 is in the tens column, so in this case rounding to 3 sig figs is the same as rounding this number to the nearest 10, because that 5 represents 5 tens, 50. And to the nearest 10, this number 7,357 would be 7,360. Part B, this is just a calculator job, pure and simple. So work this out. You can't go too wrong, as I say, as long as you've got a scientific calculator and you know it. So what I'd recommend as always is the Casio. So this one is the FX83 GTX, available in most good shops or of course online as ever these days. So my advice would be to type in the question exactly as it looks in the paper. So it's got a fraction, so press your fraction button. We've got a square root symbol, so type in your square root symbol. Then 17 plus 4 squared, toggle down, and type 7.3 squared. Then press equals, and do as the question says, write down all these figures. So we've got 0.1077, 981, and the last one's 356. Just double check you've got the digits written correctly. So if I compare mine to this, 1077, 981, 356. It's all good, so we're good to move on. Question 2. Jo paid £245 for her car insurance. This year it's gone up massively to £883. I hope she's not had an accident. Car insurance shouldn't go up so much like that. Anyway, the question is asking us for working out the percentage increase in the cost of her car insurance. There's a general formula for this. To work out any percentage change, we simply work out the change as a fraction of the original amount. So it's a change as a fraction of the original. But of course, we're not asked for a fractional increase. We want a percentage increase. So how do we change or convert from a fraction to a percentage? We need to multiply by 100. So here, the change we're talking about is actually how much the increase is. So from this question here, the increase in the insurance is the final amount, 883, subtract what the initial cost of insurance was, which was 245. So we just to work out on the calculator what 883 minus 245 is. So let's see what we have when we do that calculation. So 883 minus 245 gives us £638. So that is our change. So plugging this into our formula, the change is £638. The original cost of the car insurance, well, the original cost was £245. That was what it was before it increased. So the original is £245. We'll just simply take this fraction and multiply it by 100, and that'll tell us the percentage increase, which is what we wanted to work out all along. So 638 divided by 245 multiplied by 100, that gives us three significant figures, or maybe you want to do it to one decimal place. It's absolutely fine, whichever you prefer, but at least 3 significant figures. We've got an increase in the insurance of approximately 260%. So our car insurance has gone up, and gone up an awful lot. As I say, I hope Joe's okay. That would make me want to almost cry if my car insurance went up that much. But anyway, so it's not asking us about Joe's emotions, it's just simply asking what the percentage increase was. So there we have it, 260. Question 3. Complete this table of values for the equation y equals x squared plus x minus 4. I'm going to show you one of 2 ways of how we can fill in this table easily. Both ways involve a calculator. So what I would tend to do first of all is just simply substitute in these numbers which are missing manually into the calculator. Now if we've got minus values, put them inside brackets. So first of all, we're just going to input minus 3 for x here. So minus 3 brackets all squared plus minus 3 minus 4. That gives us a value of 2. So the first one is 2. When x is 0, this is actually not really needing a calculator. We just sub in when x is 0. 0 squared is nothing, plus nothing. Nothing plus nothing is nothing, just minus 4. Now as well, if we have a look at the calculator, so if we have a look at the numbers we've got so far, I mean to say, you can see here they're mirroring now. So minus 4 is repeated, and minus 2 is repeated. And so we can use this link. With practice, you get a familiar and more confident spot in this. But essentially, you'll know soon, with enough practice at quadratics, because of a symmetry about any quadratic curve, that the next one will also mirror this one. So 2 will mirror here with another 2. Now I can't do that for 3 because I've got nothing to compare it with. So when x is 3, let's just do this the normal way. So 3 squared plus 3 minus 4, which gives us 8. So those are the sets of values. Now, I did mention another way you might want to think of this. So there's a mode on this calculator, which is really useful for this. If you press Menu and scroll along and go to Table Mode, option 3, we can type in any function we want. So f of x, just think of that as being y, and just type this in as it looks. So I need an x. Now the x button here is this red one above the right bracket. Because it's in red, like alpha is, we press alpha bracket, square that, plus alpha bracket to get another x, minus 4. This g of x is if you want to plot another function. For example, you might be plotting 2 different graphs, but we can ignore this one. So just type in any number, just type in 1 or something. Or you could type in exactly what you've got here, it doesn't matter. We're going to focus on f of x. For table range, we just mirror this range of x values we've already worked out. So go from -3, end at 3. Now this step tells you what you want the numbers to increase by. Well, here our x values are increasing in 1s, so we can leave the step as 1 almost always, in fact. So let's just press equals and have a look at what f of x we've got. So when x is -3, f of x is 2, like we've got there. When x is -2, y is -2. And we've got -1, -4, 0, and -4, and so on like this. 1 minus 2, 2, 2, and finally when x is 3, y is 8. So that's quite useful. So what it only remains for us to do now is to actually plot these points on. So -3, 2 goes there. Next one, -2, -2 goes here. Be careful with the vertical scale. Each 2 small squares is worth 1 unit on the vertical scale. So -2 would actually mean 4 of these little squares going down. Just take care when you're plotting it. The next one's -1, -4, like so. Then 0, -4, 1, -2, 2 and 2, and then finally 3 and 8. So as you can hopefully see here, this follows a fairly smooth curve, but what people sometimes tend to do is see that these two values are the same, so they try to draw like a straight line here, like a curve of like a flat bottom to it, which just never happens really. So what we'd have to do, well, what I strongly suggest we do, is work out what happens between these 2 points. The curve will actually dip slightly, so it goes down to a minimum, then it'll rise back up again. By the symmetry, we can see here, hopefully, the minimum will be in between -1 and 0. So we could do with working out what y is when x is -0.5. So we can just do this on the calculator. So 0.5 squared minus 0.5, I should say, plus -0.5. Made a mess of that. I mean minus 0.5 all squared, plus -0.5, then -4. Let's see what this gives us. To go back into normal mode, we press menu 1 and type in -0.5 squared plus -0.5 -4. And we can see here that actually we get -4.25. So it does go down a tiny bit. It's basically half a square lower than these two combined. So we can add this one in as well. I've color-coded that in green just to demonstrate and highlight that that point actually wasn't one given to us in the table. We've just added that one in ourselves to get a bit of a fuller picture of how this curve might be plotted. Now we do our best to draw this curve with a smooth pen action. Use a pencil would be my suggestion. Here's one I made earlier, just to make sure I don't fluff my lines when it comes to recording like I'm doing here. So it should look something like this. And there we have it. So that's the curve, and therefore that's part B done. Part C, it says, use a graph to estimate a solution to x squared plus x minus 4 equals 0. Now, importantly, this curve is this. So we've got here x squared plus x minus 4. That's just the curve we've drawn. That's what y is equaling. Okay, so I'm just going over that in yellow, like so. I want to see when that is equal to 0. Okay, so when it's equal to 0, it just means where it crosses the x-axis. So if you imagine y equals the yellow, when does that meet the line y equals 0, essentially? So we're going to see where this yellow intersects the x-axis, which I'm just going over now in this green colour. So we can see, hopefully, that it actually intersects at 2 points So 1 point's there, and the other point is here. So for part C, our solutions are x equals minus 2.6, or as well, we could also have that x equals over here 1.6. Now, you could actually check these solutions yourselves to make sure you got them right if time allows at the end of the exam. So for example, how do I know this is right? Could I sort of check using my own mathematical knowledge? Well, yes, I could. The general quadratic equation, which we should know, and at least, very least be familiar with, is x equals minus b plus or minus root b squared minus 4ac, all divided by 2a. So here, the b is the coefficient of the x. We just got 1x, so that's minus 1, plus or minus the square root of 1 squared minus 4 times what a is. Well, a is the coefficient of x squared. We've only got 1x squared, so again, that's 1. Times c, which is minus 4. And all of that divided by 2 lots of 1. So I'm saying we don't have to do this. This is just a check if we need of these two solutions. So if we do this on the calculator just to double check and see if we're on the right lines, we've got here minus 1 plus square root 1 squared minus 4 times 1 times minus 4, all over 2 times 1, which I'm just going to call 2. We get here 1.56, which would round to 1.6, which we've had here, look. The other option is when we've got minus this root. So change the plus to a minus just by toggling back on the calculator display, press equals. And we get this value, which again, you can see would round to minus 2.6 to 1 decimal place, which we've got here. So I'm just referencing how we can use our calculator and maths knowledge to our benefit and double check answers sometimes if time will allow at the end of the exam. Question 4 is this diagram here. So we've got a chart, a bar chart. So Franz asked 40 students how many books they bought last year. So this chart is showing information about the number of books they bought by 40 students. Work out the percentage of these students who bought 20 or more books. So 20 or more. Well, 20 or more is just these folks here. Okay, these folks we can see represent 2 people. The height of this bar is 2, so that's just 2 students. So the percentage of students who bought 2 or more books, well, 2 students out of 40, because remember there's 40 students, so as a fraction, 2 out of 40 bought a book. But to change from a fraction to a percentage, we multiply that by 100. Now again, if you don't like this, use your calculator by all means. That's the whole idea of what a calculator is. It's a calculator exam, so treat yourself. So 2/40 multiplied by 100, that's going to give us 5%. Part B. It says show that an estimate for the mean number of books bought is 9.5, and you must show all your working. So what we need to consider here is how can we convert this into a frequency table essentially. So the big link is we can get this data and record it like this. So here there's 5 bars, which are 5 classes. Now we can estimate the mean by taking the midpoint of each one. So it's tempting to think the number which is halfway in between 0 and 4 is 2, but actually, if you just write down all the numbers here that between 0 and 4 represents, that's 0, 1, 2, 3, or 4 itself. So here, it'd actually be 2 being the middle one, okay? So we would be right in terms of thinking that was 2. But if in doubt, just write out the numbers and literally be circling the middle one. So that's got a midpoint of 2. Likewise, from 5 to 9, that has a midpoint of 7. Over here, 12, 17, and then 22. For frequencies, well, these have been recorded for us here using the height of the bars. This is between 10 and 12, so that first bar has a frequency of 11. Second bar is 8 high. The third bar is the highest at 13. From 15 to 19, that's 6. And 20 to 24, that's only 2. I now think of this last one as midpoint times frequency, but some teachers and some schools think of this as FX, frequency times midpoints. So here, first one, 2 times 11 is 22. The next one, 7 multiplied by 8, that gives us 56. This next one, 12 multiplied by 13, if in doubt use a calculator, I believe that's going to be 156. Yep, but use a calculator all the same. What's 17 times 6? Just check with your calculator, of course. Gives us 102. And finally, 22 times 2. Again, why not? That's going to give us 44. So these numbers, this final row in particular, are the crucial numbers. So we can estimate the mean squiggly equals for an estimate. It's going to be the sum of the fx values divided by the total frequency, how many students there were. So here, if we just add up all these I've highlighted in the blue and divide that by the total frequency is just how many students there are. It's clearly 40 because the question says that. So if we add these up together, what that'll give us, in fact I'll make some more space for myself down below. That's going to be 22 plus 56 plus 156 plus 102 plus 44. And all of that we're going to divide by 40. And with any luck, this will come out at 9.5, but let's just see. So, 22 plus 56 plus 156 plus 102 plus 44. All of that's going to be divided by 40. Press equals 19 over 2. Press SROD to get it into a lovely decimal. It is 9.5, as we wanted to show. So we've proven that a suitable estimate would be 9.5 by the result we've just got, so the question's done and dusted. Question 5. Lara's a skier. She completed a ski race in 1 minute and 54 seconds. The race was 475 meters in length. Lara assumes that her average speed is the same for each race. Using this assumption, work out how long Lara should take to complete a 700-meter race. Give your answer in minutes and seconds. So, let's think about this one carefully. There is a formula triangle for speed, distance, and time. So, for this one here, the formula for speed, distance, and time is SDT. Speed is distance divided by time. You can think of this in a rather silly way by thinking of this in terms of sausages don't talk. It works because that's actually true. Sausages do not talk. However, I'm not going to use this formula triangle as such. We're going to think of this in terms of a ratio. So we're going to think of speed as a ratio of distance to time. So she's assuming that her average speed is the same for each race. So based on this assumption, how long would it take her to do a 700-meter race? So she does 475 meters in 1 minute 54 seconds. Now 1 minute 54, 1 minute 60 seconds, 54 seconds is obviously 54 seconds. Add those two together, we get 114 seconds. So 475 meters takes 114 seconds. So to build to 700 meters, well, let's just think about how long it'd take her to do 1 meter. So how can we go from 475 down to 1? Well, we can divide by 475. If we do that to this side, we must do the same to the other. So 114 divided by 475. That gives us 6/25, 0.24. So each meter only takes about 1/4 of a second to do, which makes sense. Skiers can go pretty fast. Now we've got this, we can build up to 700 meters. So to go from 1 meter to 700, we multiply by 700. So therefore we do the same to the time. So 0.24 times 700. So if we do that, we get 168 seconds. But of course, the answer needs to be in minutes and seconds. So 168 seconds well, how many full minutes is 168 seconds? Well, a full minute is 60 seconds. So if I take away 1 minute, I've got 108 left. Take away another minute. I've taken away 2 minutes now. I've got 48 seconds left. So it's 2 minutes and 48 seconds. I will also introduce you to a fairly cool function of your calculator, which takes time to practice and get comfortable with. But let's say you did want to use this speed equals distance over time function. What we could have done is we could have worked out her speed. So as an alternative, which I'm not actually recommending here, but if you're a bit calculator savvy or are quite interested in, these things, then I'll show you how to work out her speed. So speed is distance divided by time. So I'm going to show you now how to type this in a special way. So based on what we were told, she covers 475 meters, and it took her a time of 1 minute 54 seconds. You can type in time in terms of hours and seconds using this button here. 1 minute and 54 seconds. Put in the hours first, so that's 0 hours. This is like a punctuation between hours, minutes and seconds. 1 minute 54 is no hours. It's 1 minute and 54 seconds. Press equals. We get 15,000. So her speed, now we use units of distance of meters. So that's meters per hour. Okay. Now we can work out the time it would take her to cover 700 meters. If I cover up time, I get distance over speed left. So d over s. So that would now be 15,000. Sorry, for distance. I apologise. For distance, it'd be 700 meters. We divide it by 15,000. But here's the beauty of it now. So if I now do 700 divide by 15,000, you might be thinking, well, that's not helpful at all. But now, if I were to take this value, I can convert it into hours, minutes and seconds by pressing this button here. So if I press that, look, perfect. No hours, just 2 minutes, 48 seconds. Maybe I'm a geek, maybe I'm a bit sad. I think that's pretty cool. It's a really nice button to use. Not many people use it because either they've not been taught it or they're not confident with it, but I think that's a pretty cool button. Experiment if you want to, or if you prefer my original method, just ignore what I've said there, to be fair. Let's have a look at part B. Part B, Lara's assumed, like we've said, that her average speed is the same for each race. But in actual fact, Lara's average speed, it actually increases the further she goes. How does this affect your answer to part A? Well, in part A we were given an estimate of how long she'd take to cover 700 metres. 700 metres is further than the 475 she went first. So if she's going further, her average speed, because it increases, her average speed for that 700 metres will be faster than what it was for 475. If her average speed is faster, she won't take as long. So essentially for part B, we just need to say something along these lines. Essentially, my answer for part A will decrease, or in brackets, just her time will be faster. So say one or the other, or just combine them into a sentence like this, and that's absolutely fine for you picking up your mark. So that's question 5 sorted out. So, question 6, we have a triangle problem to attempt. So ABC is right-angled, as we can see by this little square in the corner at angle C. AC, we're told, is 14 centimetres, and we're also given angle B and angle A as a ratio. So the size of angle B to the size of angle A is 3:2. So angle B is 3 parts for every 2 parts that angle A is. So we now need to just put this into a context and try and work out the sizes of angle B and also angle A. So we're told angle B, that's one which is 3 parts big, angle A is 2 parts big. So essentially this boils down to a ratio type problem because we need to find out the size of either B, A or both. But this all hinges on basic knowledge of angles inside a triangle. Inside a triangle, all the angles add up to 180 degrees. So we know this one's 90, and so what we can say here is angle A plus angle B plus angle C. We know that needs to add up to 180 degrees, because it just always does. However, angle C is 90. So A plus B plus 90 equals 180. So therefore, although we don't know what A and B is yet, we do know that A plus B, if we just take 90 degrees from both of these sides of the equation, A plus B must add up to 90 degrees. And this is our way in to solving this question, essentially. A plus B is 90. So what we now need to do is use this ratio fact that angle B is going to be 3 for every 2 that angle A is. So angle B to angle A is 3:2. So we can now construct this using a ratio table or something similar. So be careful here, because angle A and angle B, these are swapped in the ratio, so actually angle B is mentioned first. Okay, so angle B is 3 parts, angle A is 2 parts. So actually, if I write it like this, angle A and angle B, it's actually going to be 2 to 3. Anyway, the total number of parts for that is clearly 5. But we need the total to relate to 90 degrees. So the question here is, how can we go from 5 parts to 90 degrees? What can we multiply by? So what we need to think about here is what number we can multiply by. With ratios, the relationships are either divisive or multiplicative. So what we can do here is we can work out what number that is by doing 90 and dividing by 5. So 90 divided by 5, that gives us 18. So that tells us that we need to multiply each value by 18. If we multiply the 5 by 18, we need to do the same to the other values too, to keep the proportion in balance. So angle A is actually 2 times 18, that's 36 degrees, and angle B will be 3 times 18, which is 54 degrees. So we can label these on. So that's 36 degrees, and that's 54. We need to find the length of AB now, though, so let's label this on. So AB is this top side of the triangle. That top side is the longest side, so actually this is the hypotenuse, what we're trying to find here. So it's just a case now of what angle do you want to pick. You can use whichever angle you want to use, really. So I'm going to go for 54 degrees. Okay, so my angle I'm going to pick is 54 degrees. So if I was picking 54 degrees, then relative to the angle I've picked, the side opposite to that angle is 14. So that's the opposite side. And the other side, which isn't the opposite or hypotenuse in a right angled triangle, is called the adjacent. If you're wondering, well, why didn't he pick the 36 degree one? I'll come back to that before I finish off the question. But because it's a right angled triangle, I want to find a side. This is a case of trigonometry, SOHCAHTOA. So let's just remind ourselves of the SOHCAHTOA triangles. And the fact I'm picking 54 degrees, let's just highlight in the side I know. So the side I know is actually the opposite. Okay, so I know the opposite side because we're told that's 14. So in all these triangles, highlight O for opposite. Next, highlight what I want to know. I want to work out AB, which is the hypotenuse, so highlight H. You then pick whichever triangle gives us the most information, whichever one's the most coloured in, essentially. So the fact I've picked this angle, I'm going to be using the SOH triangle, because that's got 2 coloured in bits, rather than all of these which just have only 1. So SOH. So what does the S stand for? Well, the S stands for sine of whatever angle we've got in question. So it's S for sine of 54 degrees equals O on top, so that's 14, divided by the hypotenuse. That's what it means. Okay, so next we can just simply think about rearranging this. So I want to work out H, so multiply both sides by H. That gives me H sine 54 equals 14. And therefore, if I just divide both sides by sine 54, I then worked out H, which is what I wanted to do all along. So therefore, H equals 14 divided by sine 54. So 14, sim button is here, press 54, close the brackets, press equals 17.3. With the 3 significant figures, we've got 17.3 centimetres. Now I did promise I'd mention what if you picked A as the angle you wanted to go for. If I had have picked A, the opposite side to angle A would have been this side here, BC, which I didn't know. Relative to 36 degrees, relative to A, I would have known this would have been the adjacent, okay? I would have known the adjacent and have been wanting to find the hypotenuse, because relative to the 36 degree angle, this side here is the adjacent side. So what I would have done in this case is I would have been picking K, because I know the adjacent, I would want to find the hypotenuse. In that case, we would have started off saying cos 54 equals 14 divided by h, and we would have rearranged it in exactly the same way pretty much, but our final step would have been to have done 14 divided by cos 36. And again, we would have come out with exactly the same, so feel free to try that yourselves. Could you get the same value, 17.3, by picking this angle or that one? Question 7. We've got this table giving information about the speeds of 70 cars. Draw a frequency polygon for this information. Well, the pleasing news is this is actually very straightforward indeed. Okay, the only thing we need to consider here is the midpoints. Okay, all we need to do is take these speeds, which are in groups, and work out the midpoints of them. And this is really straightforward, I promise. Between 0 and 10, what number's halfway between 0 and 10? Well, that's just going to be 5. Halfway between 10 and 20, that's going to be 15. Halfway between 20 and 30 is 25, and the last one's 35. So we're actually plotting these points here. We go along to the midpoint and up to the frequency. So this first point is going to be 5 along, 14 up. So that point is going to be here. The next one, 15 along and 18 up, is going to be that one. 25 along and 26 up is going to be that one there. And then finally, 35 along and 12 up is going to be that one here. The final step is we draw these points with a straight line from point to point. Oops, that is not what I wanted to do. Go back. And there we have it. That's our frequency polygon. Simple as that. Question 8. We've got a diagram of a solid metal cuboid. So we're told that the areas of the three faces are marked on the diagram, which they are. 45 cm for the front face, 15 for the side, and 27 for the top. Now the lengths in centimetre of these edges are whole numbers, and this is going to be key to being able to answer this question. The metal cuboid is then melted down and made into small cubes. Each of the cubes has sides of length 2.5 centimetres. We need to work out the greatest number of these cubes that can be made from this big cuboid once it's melted down and formed into smaller cubes. So a cuboid obviously has a volume. So the volume of a cuboid will be key to answering this question. The bigger the volume of a cuboid, the more these cubes can be made. So how do we find the volume of a cuboid? Well, you should know, and I'm probably guessing you do know, the volume of a cuboid is the length multiplied by the width multiplied by the height. So let's think about the length here. Let's highlight the lengths, the sides which are the lengths. Let's highlight those in red first of all. Next, let's highlight the height in blue. So the edges which represent the height, I'm going to put in a blue colour. The length we can call A. So if we do the heights in blue, we can call those B. And if we do the widths or the depths, as we sort of go into the screen, if you like, I'm going to highlight those in green, and I'll call these lines C. So the volume of this will be A times B times C. Now, we need to now think about the information we're given in terms of the areas of each face. So let's look at this front face first of all, which is 45 cm squared. Each face of a cuboid is rectangular, so the area of the front face is going to be the length of it multiplied by the width, or in this case, the length times by the height. So A times B, whatever A and B are, must give us 45. Looking at this side face here, which has an area of 15 cm squared, this face will have an area given by what we get if we multiply B and C together. So judging by this one, B times C, BC, must be 15. And finally, this top face, which I'm going to highlight in purple, has an area of 27 cm squared. The area of this one is obtained by multiplying A by C, so we can also say that AC is 27 cm squared. So this may now look like a set of three simultaneous equations and might seem quite daunting, but actually we can do this simply using trial and error. So we can pick any of these faces first. I'm going to suggest we just go for A and B. So A is the length, B is the height, and we can see that A is going to be greater than B. So A is going to be our bigger number and B is going to be our smaller number. And remember, the edges are whole numbers. So think of two whole numbers that would multiply together to give 45. Well, could it be as simple as 45 and 1? I'm going to put a question mark because I honestly don't know. If A is 45, and B is 1, then what would C have to be? Well, for this one here, C would have to be 15, because 1 times 15 gives us the 15 we need. Looking at the top here, A, 45 times C, can that ever give us 27 if C is a whole number? Well, it can't, because 45 times 1 is already too big. So C would have to be some decimal, which isn't allowed, because C has to be a whole number. So 45 and 1 doesn't work. So we go back to the drawing board and just try something else. So let's make the length slightly smaller. So we could have maybe 15 and 3. Would that work? So imagine A is 15. And B is 3. This face here, if B is 3, C would have to be 5, because 3 times 5 gives 15. But then if I put C here to be 5, then obviously that doesn't work. Another way of seeing that it won't work is 15 times something can never be 27 if that something's a whole number. 15 times 1 is 15, 15 times 2 is 30. So again, C would either have to be a decimal, and it being 5 surely doesn't work either. So 15 and 3, that just doesn't work either. But never mind, keep going. So making A slightly smaller, the next one we could try would be 9, because 9 and 5 are two whole numbers that multiply together to give 45. So let's try those. So if A is 9 and B is 5, then C, looking at this one, would have to be 3, because 5 times 3 is 15. And if we try C being 3 here, voila, it works, because 9 times 3 is 27 as well. So A being 9, B being 5, and C being 3 works. So therefore, we can see that A has to be 9, B has to be 5, and C must be 3. And from that we can see what the volume of it is. So the volume is going to be A times B times C, which is 9 times 5 times 3. Let's let the calculator do the hard work. 9 times 5 times 3 gives us a volume of 135 cm cubed. Now, like the question says, this is going to be melted down and made into cubes. Each of these cubes has sides of length 2.5 cm squared. So if we just for a moment think about these cubes, then they're going to be looking a bit like this. So it's going to have a front face, it's going to have width and length, like so. Not the best cube in the world, I know that much. But anyway, so let's imagine that being a cube. Each side's 2.5. So the volume of each cube will just be 2.5 times 2.5 times 2.5, literally 2.5 cubed, which again we can employ the calculator to do for us. So 2.5 cubed, that gives us 15.625. So how many cubes can be made from 135 cm cubed? Well, we can work this out by doing 135 divided by 15.625. So 135 divided by 15.625. So we've got this answer stored. If we just do 135 divided by our stored answer, A and S, we get 8.64. So that means 8 and a bit cubes can be made. Obviously it's either a cube or it's not. So this 0.64 just means some of this metal which is left over, which isn't quite enough to make a whole cube in itself. So the total number of complete cubes that can be made is 8. So our final answer is we can construct from this metal 8 cubes. Question 9 is algebra in all its forms. Well, not all, but a few. First of all, part A, we have to expand and simplify 3 brackets multiplied together, x minus 2, 2x plus 3, and x plus 1. There are mainly 2 ways of doing this. Either expand out the first 2 brackets first, and then do the third one after, or expand the last 2 brackets out first, and then multiply all of it by the first one afterwards, which in this case is x minus 2. Each teacher and each student will have their own preferred method. My preferred method is to expand out the last ones first, and then deal with the first bracket last. Sort of work it the wrong way around, the inside out. So first of all, let's leave the x minus 2 as it is, and focus on expanding the 2x plus 3 and x plus 1. So when we do this, we can take the 2x and multiply by x. That's going to give us 2x squared. Then 2x multiplied by just for 1. Anything multiplied by 1 stays as itself, so that gives us positive 2x. Next, 3 multiplied by x gives us another positive 3x, and then 3 multiplied by 1, 3 times 1 is just, obviously, 3. So in the yellow, we've expanded these brackets, and it's become this. That's what we've got. The next stage is to now multiply what we've got from this first step with the x and then the minus 2. So if we do that, we can take the x and multiply it in turn by all of these terms. But before we do that, let's simplify what we have underlined in yellow. So 2x squared, there's only one x squared term, which is the 2x squared. However, positive 2x and the positive 3x we can group together to be positive 5x. And the plus 3 is just standing alone like so. We can then multiply the x by everything in the second bracket, and then do the same with the negative 2. So going again, x times 2x squared, x multiplied by 5x, and x multiplied by positive 3. So in turn, x times by 2x squared will give 2x cubed, x multiplied by 5x will give 5x squared, x multiplied by 3 is just 3x. Then we do the same with the negative 2. So we multiply everything by minus 2 in the second bracket. And if we do that, I'll get minus 2 multiplied by 2x squared, which is minus 4x squared. Minus 2 multiplied by 5x, that gives minus 10x. And finally, minus 2 multiplied by positive 3. A minus multiplied by positive gives a negative, so we have minus 6. So that's a case of grouping everything together. So 2x cubed, when you have one x cubed term, the x squared terms, we actually have 2. We've got a 5x squared and a minus 4x squared. 5x squareds take 4x squareds, will give just plus 1x squared. Then we have a 3x, but also a minus 10x. 3 take away 10 is minus 7. So 3x take 10x will leave us with minus 7x. And finally, minus 6 on the end. Obviously, it's just minus 6. So that's what we'll have. However, I do know that's not the only way of doing it. So if, for example, you were of the opinion of trying to multiply the first two brackets first, here's what you should have got, if not something very, very similar. So if we multiply out the next two brackets, what we'd have is this. So that's if we expanded the leading two brackets first. Your answer would look something like this. Importantly, though, the final answer would be exactly the same as what we get if you multiply the last two brackets first. Let's have a look now at part B. So part B is a laws of indices type question, and we're asked to find the value of n. So, first of all, we can take this and apply the laws of indices directly. So, we'll leave the y to the power n on its own and just hone in on the y to the power 4 over y squared. And if we divide the base values are the same, we simply subtract the powers. And so 4 minus 2 will leave us with y squared. And the y to the power n is left as it is. In case this step confuses, I'm just going to put it over here, longer hand. So y to the power 4 just means we've got 4 y's in a line, all multiplied together. Y squared means 2 y's multiplied together, and of course for y to the power n, I'm going to leave on its own. If you did it this way, which I'm not recommending, this is just more to see why the rules are the rules, we can cancel y's on the top and y's on the bottom. So that y will cancel with that y, this one with that one, which will just leave us with y squared on top, y times y, multiplied by y to the power n. So therefore, we can say this, which is this thing here, must be equal to y to the power negative 3. Here, though, we're taking base values with indices, and we're multiplying one by the other. If the base values are the same, another law of indices tells us we can combine these two powers by adding them together. So y squared multiplied by y to the n is the same as a single power, y to the power 2 plus n. And that equals y to the power negative 3. Let's just inspect this and think about it before we proceed. So we have one side equal to the other side. Both the bases are the same, y under y. So if one side is equal to the other and the bases are equal, that can only be the case if the powers are also equal. So therefore, from this we can deduce that 2 plus n must equal negative 3. So therefore, 2 plus n equals negative 3. Now if we subtract 2 from both sides to leave n on its own and giving n as the subject, we'll see that n is minus 3 minus another 2, which is minus 5. So this is solved by realizing that n equals negative 5. Let's finally have a look at part C. So part C tells us to solve this quadratic, which is equal to 0 on the other side, give your answers correct to 3 significant figures. The fact that the question says give your answers correct to 3 significant figures is a massive hint that this won't factorise nicely. So what we're going to try to do here is remember the quadratic formula, and the quadratic formula is, of course, this. X equals minus b plus or minus square root b squared minus 4ac over 2a. If you're rusty, you might be thinking, well, what does a mean, what's b, and what's c? Well, a is the coefficient of x squared. The b is a coefficient of the x term, which is minus 4 in this case. And the c is the number on its own, the constant term, which is negative 3. So let's just write down what A, B and C are. A is 5, B is -4 and C is -3. Once we know that and have established it, we need to now just plug these numbers in to this quadratic formula. By the way, this only works when all of this is equal to 0. If, for example, that are equal to -10, we'd have to add 10 to both sides to get it into the standard form. We can only apply this formula when we have a quadratic equal to 0, which is what we do actually have. So we don't need to rearrange in this case, but if we did, just remember what I've said here. So, sticking these numbers into the equation, over here, we can see that x is going to be, let's get the fraction line drawn out ready, x equals -b, which now, and this is going to be a double negative. So in our case, -b is going to be -4. So I'm going to write it down so you can see where the numbers come from. But obviously you should interpret a negative as a positive. So -4 plus or minus the square root of b squared. So that's -4 all squared. Subtract 4 multiplied by a, which is 5, multiplied by -3, which is our c. And all of that's going to be divided by 2 lots of a, which in our case means 2 lots of 5. So just colour coding where these numbers come from. So 2a, that's 2 times 5, minus 4ac is -4 times a times c, and the -b, -4, and the b squared is -4 squared. So it's just a case of processing this in the calculator and being careful when we type in the values. So first of all, what we need to do here is to do the fraction line. So press the fraction button. -4, you can put as just +4 if you want to. First of all, I'm going to do the negative square root. We can change this to the positive one after. So -4 squared -4 multiplied by 5 multiplied by -3. Then the bottom, 2a, is 2 multiplied by 5. So, first of all, to 3 significant figures, we have this third. If we press S arrow D, we can convert it into a decimal form. So we have -0.472 to 3 significant figures, because that 7 next to the 1 forces that 1 to round up to a 2. So -0.472 and the other value is the positive option of this root. So we can actually do this by toggling back and changing this negative into a positive. And if we do that, we get this here, which if we press S arrow D, we get 1.27. And those are our 2 roots of this quadratic, -0.472 or 1.27 to 3 significant figures. Let's next have a look at question 10. Question 10, we have f of x equals 4 sine of x. We have to find f of 23, giving answers correct to 3 significant figures. Here's my little tip for function questions. The tip being a very simple one. Whatever the input of a function is, almost always an x, or a y sometimes I suppose, put this in brackets in terms of what it equals. So here we have 4 sine x. So protect the x, wrap it in cotton wool, put the x here in brackets as well. So why is my tip to do this? Well, put simply, it's to make it easier in terms of what we substitute in place of x. So here, what we're saying, we don't want f of x, we want to work out f of, in particular, 23. So what we're doing here is we're going to swap the x with a 23. So therefore we can say that f of 23 equals 4 sine of 23, which we can then just pop into the calculator and it'll come out correct. Job's a good one. So f of 23, if I just move this to the side, we have that it's 4 sine, or sin if you prefer, 23, close brackets. We get 1.56 to 3 significant figures. So our answer, 1.56. So what does part B have in store? Well, part B, we're now talking about a composite function. We've got this new function g of x defined as 2 lots of x minus 3. Find fg34. So we need to remind ourselves what f of x was. So we've got f of x, which was 4 multiplied by sine of x, which, if you remind yourselves, you've got to go back. It was 4 sine of x. If you don't believe me, there it is. And g of x, using the same idea here, put the input in brackets. So I'm going to put this x inside its own bracket. So we have 2 lots of x minus 3. So fg of 34, how do we work that one out? Well, we start at the end and then work backwards. So we don't do f first, we need to work out what g of 34 is first. The way of thinking of it is, imagine this g of 34 in its own invisible brackets. So BIDMAS, do these first, then work outwards. So what is g of 34? Well, g of x is 2 lots of x minus 3. So if we take this definition and substitute in 34 in place of x, we can hopefully see that g of 34 will be 2 lots of 34 subtract 3. We're just switching an x with 34. That's all we're doing. So 2 multiplied by 34, use calculator if you wish to. 2 times 34 is 68, minus 3 gives us 65. So we can do this and substitute it into this expression here. So g of 34, we said, was this, which gives us 65. So showing it step by step to the examiner, it's f of g of 34, which is 2 lots of 34 minus 3. And like we have seen before, that equals 65. So we do f of 65. Now the function f of x takes the input and maps it to 4 lots of sine of x. So if we just take this here and substitute off x and substitute on 65, you can hopefully see that f of 65 will be 4 multiplied by sine of 65. So again, showing this clearly and unambiguously to the examiner, we would say that this is therefore going to equal 4 sine of 65. And that's going to come out to be, well, to be honest, I don't actually know. That's why I need a calculator. I'm not that good. Far from it. So 4 multiplied by sine 65, close brackets. That's going to give us 3.63, because next to a 2 is a 5. 5 or more we round up. 2 becomes 3, so we have 3.63. And that, you'll be glad to know, finally, is our answer. 3.63. We're done. We can move on to the next question, so let's do so. h of x equals x plus 4 all squared. So Ivan needs to solve the following equation, h of x equals 25. This is what he writes down. It's not fully correct. Explain why. So my suggestion to you is to do the question yourself, have confidence that you know how to do this question, correct his version of it by comparing your correct version to his incorrect version. So as long as you've got confidence, you can see the error by spotting the difference between your correct one and this incorrect example. So how would you solve hx equal to 25? Well, like the question said, h of x is equal to x plus 4 squared. So the first step would be to say x plus 4 all squared equals 25. Compare this with what Ivan said. Well, that's what he said on the first line, so that seems okay to me. So what he's done here is he's square rooted both sides. So the square root of something squared is just the thing without being square rooted. And he's put 5. Square root of 25 is 5. On the surface, that seems fine. However, if x plus 4 were negative 5, negative 5 squared would be negative 5 multiplied by negative 5, which would be positive 25. This is a general rule with maths. When we square root something, we need to consider both a positive and negative square root. Ivan has not done that. That's his mistake. So it's not fully correct. Explain why. Well, an explanation could go something like this. Importantly, we need to say that x equals 1 is not the only solution. There'll be another solution when we consider that x plus 4 is negative 5. So here's a potential answer you could give. So Ivan has only considered the positive square root when both a positive and negative square roots are required. There should therefore be 2 solutions, not just for one. So x equals 1, which he's got, that's correct, but also x equals negative 9. So if x were to equal negative 5, x would be minus 5 minus another 4, which would be minus 9. So those are the roots, and that's a possible explanation. So something along those lines would pick you up the marks for 10 part C. Question 11, we have to sketch a graph of y equals 10x for x being between 0 and 360 inclusive. You may have seen this before in maths class. You might know how this graph looks, but I'm going to go off a premise that you've forgotten or you don't know or you've not seen it and build it up from the basics. What I would suggest to do would be to start from what the examiner's told you. The examiner's told you the points 0, 90, 180, 270 and 360. So let's do tan of each of those values and see what we get. So we can just build this up using the calculator essentially. So first of all, what's tan of 0? So what I'm going to do here is just press tan 0. I'll put this in a different order actually. I'll put the calculator here and the answer box there. So tan 0 is 0. Okay, fair enough. So we can plot that it goes through the origin. So 0 and 0 is a point on this graph. Next we have is tan 90. So let's try that. So tan 90. Whoops, the calculator's blown up. So, okay, we'll come back to it in a moment. So I'm just going to highlight 90 as a problem point. We'll examine that in a moment. How about 180? Well, tan 180. Again, that's 0, so that's easy to plot. Tan 270, we'll try that now. So tan 270. Calculator just blows up again. Math error. It's not liking it, so we'll examine 270 in a moment. And the final one, tan 360, we can analyse that easily enough. Let's just press tan 360 in. See what happens. Tan 360 comes out to be 0 again. So we've got 3 points lying on the x-axis and 2 points here which are problematic. So let's see what happens if we go from 0 towards 90. That will be a bit of a clue, won't it? So what's happening as we go from 0 to 90? So what we can do here is just try different values of different values of x if we get close to 90. So let's, for example, try tan of 10. What's tan 10 degrees? Pretty small, 0.176. Tan 20, 0.4-ish, it's getting bigger. Tan 30, 0.6-ish, so it's getting bigger still. Tan 40, 0.8, that's doubled almost, so it's doubled to 0.8. So 0.8 was the last one, go up another 10 degrees to tan 50. That's gone up quite fast as well, so 1.2. Tan 60, it's gone up by 0.5. Tan 70, it's going up faster now. So as we're getting closer and closer to 90, the graph of tan of x is getting quicker at an increasing rate. So it's going something like this. It's going slowly, 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 but it's going faster and faster and faster as we get close to 90. So what's that about? Well, let's try tan 80 next. 5, so it's gone up loads from tan of 70, so it's going up really steep now. So as it gets close to tan 90, obviously we know tan 90 just blows a calculator up. What about tan 89? 57. That's really big. How about tan 89.999? That's in the thousands. A bit more, it's in the millions. So what will happen as we get closer and closer to 90, it's going to blow up. So actually what happens is, as x approaches, but can never be equal to 90 degrees, tan of x approaches a value towards infinity. So this is going to shoot off towards a vertical gradient as it gets closer and closer to 90. That's what we've shown by just trying these different values on a calculator. So we can add this in to our sketch. It's important to put a dotted line on the sketch. Very important indeed. The dotted line denotes what's known as an asymptote. An asymptote is a straight line which a curve approaches but is never quite allowed to actually touch. So this graph here is going to get closer and closer to this dotted line without ever actually quite touching it. So how about the other side of 90? So let's make it just a bit over 90 and see what happens. How about, for example, 90.001, just slightly bigger than 90? You get something hugely negative. And indeed what happens here, as you can see if you put more zeros in, so it's just a tiny, tiny fraction bigger than 90. It's coming out as negative infinity towards. So this graph is going to be flipped on the other side of 90. It's going to be something like this. And goes towards 180 where it crosses the x-axis. And again, I'll leave this to your own judgment and for you to experiment. You'll find the same picture as we go towards 270. As x gets closer and closer to 270, the same thing will happen as what happened at 90. I'll leave that to you to experiment with and play with, just so that you can actually convince yourself that what I'm saying is true. When you convince yourself of your own truths, it's much more powerful than if someone tells you that something's true. So the same will happen here. Goes up towards infinity, but never can actually get to that, of course. After 270, the same thing happens. Comes up and evens out, so it goes through at 360 as well. As you can see, my graph is a bit shaky, a bit wobbly. So here's one I made earlier with perfect graphing software, which looks perfectly smooth. Nothing wrong with it. In a perfect world, your graph would look something like this. So it's important to draw those dotted lines in at 90 and 270. To get full marks, start from 0, 180 and 360 where it crosses the x-axis, and a smooth curve up from 0 towards 90 going vertically. between 90 and 270 of this S shape, and from 270 to 360, half of an S shape. That will get you full marks. Question 12, we've got a square-based pyramid ABCD. We're told that AB is 5 meters. So AB, as you can see, is a length of this square base. So AB is 5 meters. Let's focus in on that. Because it's square-based, AB, which is 5, will be the same as BC, which is the same as CD, which is the same as AD. The square has all the sides the same length. So all these sides in red are going to be 5. So what else are we told? We're also told that this vertex T is 12 meters vertically above the midpoint of AC. So T is this one here. So this T is going to be 12 meters higher than the base of this square, and more than that, it's vertically above the midpoint of from A to C. So what's AC? Well, AC is the line from A to C. So let's just draw that in first of all. There it goes. And T, from T to this midpoint, is 12 meters high. It's 12 meters vertically above it. So let's add in a line in blue, denoting that T is 12 meters higher than this midpoint from A to C. So next, we need to calculate the size of angle TAC. Lots of information in this question and not much words. So TAC, middle letter rule, we want to find the angle at A. So if we go from T to A to C, we're trying to find this angle here, which I'm going to colour in and highlight clearer than what I've just done here. TAC, this one, I'm going to colour it in green. It's this angle here. So, how do we solve this question? Well, it says here that the vertex T is above the midpoint of AC. So I'm going to call that M. I'm going to call that M for the midpoint. I'm going to just take this triangle from T to A to M, triangle TAM, and draw it over here. So can we work out this distance from A to M? That's what I'm trying to do here. Well, I can't know the distance. We can't know the difference from A to M unless we know this distance from A all the way to C. Because from A to C, we know that this here is going to be a right angle because it's a square base. We can work out A to C actually by using Pythagoras. And so that's what we're going to do first off. So let's use Pythagoras' formula. That's quite a bad sketch actually. Let's make that a bit more realistic looking. That's a bit better. So I'm going to call this A, B, C. We know that AD is 5, like so, and DC is 5 as well. So we can work out AC here. So we can use Pythagoras for this, to be honest. So AC, which is hypotenuse because it's opposite to the right angle D, it's going to be the square root of these other two sides square rooted and added together. So it's going to be 5 squared plus 5 squared, which equals root 50. So therefore, AM that's going to be, because it's only halfway from A to C, it's going to be half root 50. So what is half of root 50? Well, luckily it's a calculator exam, so let's try that. So half of root 50 gives us, roughly speaking, 3.53553 4. So 3.53, double 5, 3, 4. So we're going to add this in here. So 3.53, double 5, 3, 4. I'm not rounding at this stage because this is not our final answer. So I'm just writing in from A to M is this number here, this value, which is the decimal approximation of a half root 50. So we know AM. So let's just zoom in on this triangle TAM for a moment. So TAM. This is the full decimal approximation on the calculator for AM. I said it's about 3.53. It is. This is it a bit more accurately. We also know from T to M is 12, because T is 12 meters vertically above the midpoint. So we know that's 12. We know A and M, A to M rather, is 3.53-ish. So let's just think about this now. It's a right angled triangle. M's a right angle. We know two sides. It's therefore a trigonometry question. A triangle which is right angled, we need to be thinking in terms of SOHCAHTOA. So let's think in terms of these magic trigonometry triangles. Which one are we going to use? Well, we're trying to find angle TAC, which, by the way, because M is along AC, that's the same as saying I want to find the angle TAM. Okay, so we can find TAC by working out TAM, which is this angle here. So it's one and the same thing, because M is on the line from A to C. So what sides do we know? Well, this is the angle in question we're trying to find. Opposite to that angle is literally the opposite side. Opposite of the angle, we call that the O side. So we know, therefore, the opposite side is 12. So in these triangles, we can highlight O for opposite, because that's the side we know. What else do we know? Well, the longest side is the hypotenuse. That's fairly obvious to spot. If you're not sure which one's hypotenuse, it's always opposite the right angle. So if this one's hypotenuse, do we know that? No, we don't. If it's not the opposite or hypotenuse, the other side is always called the adjacent, which we're going to label as A, which we do know, that's from A to M, which is 3.53. So because we know the adjacent, we can highlight this in these triangles as well. So highlight A for adjacent. And finally, which triangle is the most filled in, which is the most colourful triangle? Whichever's the most colourful is the one we're going to use. So here, TOA is the most coloured in, so we're going to use the TOA triangle. So O stands for opposite, A stands for adjacent, T stands for tan. If you remember, which hopefully you do, to work out an angle, we do the inverse functions, either sine -1, cos -1, or tan -1. Because we're going to use this T triangle for TOA, we're therefore going to use tan -1. So TAM will be tan -1 opposite over adjacent. So what is the opposite side? Well, the opposite side is 12. The adjacent side is 3.53, 5, and so on and so on. So all I'm doing here is I'm just plugging in that the opposite is 12 and the adjacent side, relative to the angle we're trying to find, is 3.535 and so on and so forth. Now, this has been stored in our calculator. So look, we've got 3.53 stored. If we press answer, it's stored for us. So we just now need to do shift tan to get tan -1, 12 over the answer which has been stored, close brackets, press equals, and here we'll have our golden answer. So to 3 significant figures, which is the golden standard in terms of what to round an answer to, 73.6 degrees. That's what we write, that's what we need to do and then we're done. 73.6 degrees is the value of angle TAM, which is the same as TAC. Question 13, we have a recurrence relation. So we're told that the number of animals in the population at the start of year T is P subscript T. The number of animals at the start of year 1 is 400. Given that P subscript T plus 1 equals 1.01 P subscript T, work out the number of animals at the start of year 3. This is actually much easier than what it might read. So the start of year 1, the population is 400. And so based off this and this notation, because T is the year number and we're told what year 1 is, we can write from this, I've highlighted in yellow, that P subscript 1, the population at the start of year 1, is therefore 400. So that's our base case, that's our starting point. So we want to get to year 3. Now, if we look here, T plus 1 just means 1 higher, 1 more year. So we have to go up in steps of 1. So we can get to P2 by using P1, then we can get to P3 by using P2. So that's just a case of substituting into this formula twice. So what it's saying here is P2, think of that as 1 plus 1, that's going to be 1.01 multiplied by P1. But we know what P1 is, because the question says population year 1 is 400. So this is 1.01 multiplied by 400, which we can work out really straightforwardly. So 1.01 multiplied by 400, that gives us 404. So we've got 404 animals. So we've got P2. Finally, P3, that's going to be 1.01 multiplied by P2. So that's 1.01 multiplied by 404. So then we'll have it. So we know what P2 is. P2 is 404. So we just need to work this out on a calculator. And obviously this is going to be the answer we wish to find. Number of animals at the start of year 3 is P3, which is what we're going to find now. So P3, 1.01 multiplied by the previous answer. We get a weird number here, so if we convert that, we get 408.04. Now, obviously, you can't have 408.04 of an animal, unless obviously it's about eating it or something, which is not what we want to think about in this question. So to section out, we've got 3 steps. So the first case is P1, and then we had P2, and finally P3, which is 408.04. But then we can conclude with this, that actually because we can't have 0.4 of an animal, the number of animals we'd have would be 408 animals. So that's all there is to that one. Question 14, we're told that y is inversely proportional to x cubed. So, inverse proportionality. There's a symbol for proportionality, which looks a bit like a fish. So we say y is proportional. Now, because it's inverse proportion, instead of being x cubed, inverse means 1 over x cubed. So that's how we put into maths this sentence. Now obviously this isn't an equation. So how do we move from a symbol of proportionality to an equals sign? Well, what we do here is, if something is proportional to something else, we can say that this thing y must be equal to some constant we don't yet know. I'm going to call that constant k, multiplied by what it is, in this case, inversely proportional to. So if y is proportional to this, y equals k multiplied by that thing, where k is some constant of proportionality to be found. So what I'm going to do here, I'm going to just write this as y equals k over x cubed. Now the next thing, we can substitute in some values to try and work out what this k is. So we're told that when y is 44, x equals a. So we're going to substitute those conditions in. So let's sub y is 44 when x is equal to a, and see what happens when we do that. So sub y is 44, so 44 equals k over x cubed. But if x is equal to a, that means a cubed. If we now multiply both sides of this equation by a cubed, we can work out what k is in relation to a. So multiply by a cubed on both sides. We get 44 a cubed equals k. Or reversing it, k is 44a cubed. So now we know what k is in terms of this a factor. K is 44a cubed. So now we need to show that y is 5.5 when x equals 2a. So based off this equation, which we can now simplify in terms of 44a cubed, we can say that therefore y equals k over x cubed. We know what k is now, so that means 44a cubed over x cubed. Now we substitute in when x is 2a. From what it's saying here. We'll then get that y equals (44a cubed) divided by x cubed, which is 2a cubed. So what's 2a all cubed? Well, we can work this out fairly easily. 2a all cubed means we do 2 cubed, which is 8, and also the a cubed, which is just obviously a cubed. Now we have a cubed at the top and the bottom, which means that we can cancel out, we can cancel the a cubed at the top and the bottom. So that leaves us with just 44 over 8. Then if you want to convince yourself, you can use a calculator if you wish. So 44 over 8 gives us 5.5 as required. So proven what we needed to prove, therefore we've nailed the question. So that's question 14 done. Question 15. Prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. So consecutive means next to. Okay, so it means one higher. So odd numbers are like so. Nothing we don't know already. 1, 3, 5, 7, 9, 11, and so on and so on. So what's the nth term of an odd number? Well, the numbers are going up in 2's, so it's going to relate to 2n. Then compare this sequence to the 2 times table. 2, 4, 6, 8. Each of these numbers are lower than 1, lower by 1 each time, I mean to say. Each of these is 1 smaller than the 2 times table, so we subtract 1. So essentially, if we carried this on, the sequence of odd numbers, in general, in terms of n, we'd come to a number which is 2n minus 1. And of course, the gaps are going up in 2's, so the next one will be 2n plus 1. Then 2 bigger will be 2n plus 3, 2n plus 5, and so on and so on. So these are numerical representatives of odd numbers. Now these here are algebraic representative of odd numbers, where n is a natural number, where n is a member of a set of natural numbers. This is some notation. Don't worry too much about this. But we're just saying, for example, n can't be some fraction or like a decimal. So n has to be a whole number. So we can now choose what we want. Because we need to prove algebraically, we need to pick 2 algebraic representatives for 2 consecutive odd numbers. Now, I would be suggesting that positive numbers are easier to deal with. So I'm going to ignore the 2n minus 1. So I'm going to look here for 2 odd numbers, algebraic odd numbers, which are next to each other. So 2n plus 1 neighbours 2n plus 3. And so I'm going to go for these 2 here. These are 2 consecutive odd numbers, one next to the other. This one is the next odd number up from that one. So, what can we do now? Well, we want to show that the difference between the squares of them is always a multiple of 8. How do you work out the difference between 2 numbers? Ask yourself a really obvious question. For example, what's the difference between 10 and 7? The difference between 10 and 7 is 3. How do you get 3? It's 10 minus 7. So the difference, just interpret that, is the biggest number minus the smallest one. That's how I find the difference between any 2 numbers. But it's not just the difference between the odd numbers themselves, it's the difference between the squares of these odd numbers. Okay, so what we need to do here is we take these 2 odd numbers and work out the difference, not between them, but the difference of their squares. So the difference is the biggest minus the smallest. So the biggest one is 2n plus 3. I'm going to minus away the smaller one, which is 2n plus 1. However, we're not doing the difference between the numbers themselves, like the question says. We're doing the difference between the squares of the numbers. So it's that one squared minus this one squared. So, in my opinion, the hardest part of the question is interpreting the question correctly in terms of what we need to actually do. If you can get to this stage, the rest of it isn't actually so bad. Now all we need to do is just expand these brackets as we would do under normal circumstances. So, the first number we've got is this one here. So what's 2n plus 3 all squared? Well, we square the first term, so 2n squared is 4n squared. We then take these 2 numbers here, multiply them together, and double. So 2n multiplied by 3 is 6n, double 6n, we get 12n. Finally, we square the last number, so 3 squared is 9. We then subtract this one here, all squared. So 2n squared is 4n squared, and 2n times it by 1 double is 4n, and finally 1 squared, 1 times 1, that's just 1. So now we can simplify this. So what this gives us here is 4n squared minus 4n squared. That'll cancel perfectly. So 4n squared will cancel with that 4n squared. 12n minus 4n, that will leave us with 8n. And then 9 plus 1, that will leave us with 8. So we have 8n plus 8. Now, because we want to prove that this difference between the squares is a multiple of 8, we need to prove that this expression here, we can factorise out an 8 from it. And we can look, both of these terms here, we can factorise out an 8 from each of these, which gives us 8 brackets n plus 1. So it's 8 multiplied by something. In other words, that's a multiple of 8. So finally, I'd always suggest with proofs to return and make a statement regarding what we're trying to prove. So in this case, I'd say, therefore, the difference between the squares of consecutive odd numbers is always a multiple of 8. And then we're done. Number 16. We've got this shape ABCD. So it's part of which looks circular and like a triangle attached to it. Like it says, it's made from a triangle and a sector centered at O and radius 6. OCD is a straight line, AD is 14, angle AOD is 140, and angle OAD, this one here, is 24 degrees. Calculate the perimeter of a shape, give your answer to 3 significant figures. So first of all, let's think about how this shape ABCD is constructed and what its perimeter would look like. So its perimeter is made up by 3 different lines, 2 straight, the green and the blue, and 1 curved, this section of a perimeter, circumference of a circle. So how can we get an expression for the perimeter of ABCD? Well, the perimeter of a shape is going to be AD in green plus CD in blue plus the arc ABC. So the arc is just a portion of the circumference of a circle. So AD, that's quite straightforward because we're told what AD is. AD is 14. So the main things to focus on are how do we work out CD and how do we work out the arc ABC. So let's focus on these first. Well, now we can fill in the information in the question. So AD is 14. So that's really straightforward. We can add this in. So first of all, what I'm going to do is I'm just going to say that we can simplify this in not too long. So the perimeter is going to be 14, which is AD, plus CD, plus this arc. So arc and CD, that's going to be where most of our work comes in. Now, this arc, we're told that this angle at the middle, AOD, is 140. So we can fill this in. So from here to here is 140 degrees. So what I'm going to do next, I'm just going to get rid of this O here for a moment, because it's just in the way. That means that on the other side, all the way around here, angles in a circle add up to 360. So if that's 140, the angle on the other side will be 360 minus 140, which is 240 and 20 degrees. So, for a circumference of a circle, how do we work out the circumference of a circle? Well, it's going to be 2 times pi times r. So it's going to be 2 pi multiplied by the radius, which we're told is 6. So the full circumference of a circle will be 2 pi r, which is this. Of course, though, this isn't the full circumference. It's just a fraction of a full circumference. A full 360 degrees would be a complete circumference. So we need to think about what fraction of a circle do we have along this red curve. Well, the fraction of the circle is given by this angle here. It's not a full 360. It's only 220 out of the full 360. So actually, the arc length will be this fraction of the circumference. So this is the calculation we need to do to work out the arc length. So let's do this next. So we're going to have 220 over 360 multiplied by 2 multiplied by pi, so shift pi, multiplied by the radius, which is 6. So as a decimal, we have 23.0383. 22.0383. Sorry, I mean to say 23.0383. Changed the 23 to 22 in my mind for some reason, which isn't a really good idea. Anyway, so 23.0383. The next bit to think about is CD. So CD is this portion of the side from O, the centre of the circle, to D. So what we could do here is we could consider this as a triangle, of which we know the side 6, we know AD is 14, and we're trying to work out OD. So let's picture this bottom triangle in a bit more detail. So this angle at A, the angle OAD, as well, luckily we're also told. So we're told here, angle OAD is 24 degrees. So if I add on here, this is 24. OA is the radius, which we're told is 6. And A to D, we're told is 14. Now, the bit we're not told, the bit we don't know, is from O to D. So what we can do here is consider what from O to D is. And because from O to D is opposite this angle A, I'm just going to label OD as A. And hopefully this will help some memories flood back to you about how we can solve such a problem. So we want to know a side opposite to an angle we know, and we know the two other sides. This is a case of the cosine rule. So if you're not familiar or you've somehow forgotten the cosine rule, you know you are human, this may happen, I'm going to remind you what it is here. So the side you want to work out, squared, is the same as the sides you do know, squared and added together. So a squared equals b squared plus c squared. Looks exactly like Pythagoras. But then we subtract two lots of the product of the two sides you do know, and we multiply that by the cosine of the angle opposite to the side you want to find out. Opposite to A, we know angle A. So that's the cosine rule, which we can fairly easily adapt. We can find A by just square rooting both sides. So therefore here we can just say that OD, which I've called A, that's going to be the square root of b squared plus c squared. So b and c in any order are 6 and 14. So I'm going to call one of them 6 squared and the other one 14 squared. So 6 squared plus 14 squared. Give myself a bit more space. Then we're going to subtract minus 2 times 6 times 14.
multiplied by cos of the angle which we do know, which we're told is 24 degrees. So if we work this one out on the calculator, move this out of the way. So square root of 6 squared plus 14 squared minus 2 times 6 times 14 times cosine of 24. What have I put in wrong here? Ah, yes. This is a point. Always close off the brackets. I need to follow my advice. So close off the brackets like so. Then it will work. So we have 8.8614 to 4 decimal places. 8.8614. Okay. However, we don't actually want to work out the whole of OD. We want to work out just CD. So CD is from here to there, okay, and from O to C is a radius. So OC, which is the radius, from O to C is just 6. So therefore, CD will just be the whole length of OD, subtract the radius. That'll be 8.8614 minus 6, which will therefore be 2.8614 centimetres. So now we have all the ingredients to work out the perimeter. So we've worked out AD, what we're told AD is 14. We now know CD is 2.8614. And we also know the arc ABC, which is 23.0383. So all what remains to do is to just sum these values. So let's do this now. So we've got 14 plus 2.8614 plus 23.0383. And to 3 significant figures, we get 39.9 centimetres. And that's our final answer. So lots of parts to this question. But as ever, if we just split it up into nice bite-sized pieces, it can be solved, and it will be solved. So 39.9 centimetres. Question 17. We've got this histogram question. So we've got a table showing information about the distances 570 students travelled to a university open day. We have to draw a histogram for the information in the table. So a bit of a giveaway here is we've got an axis which isn't even labelled at all. So we need to work out something, presumably from this table, and this axis here isn't labelled. So what do we need to know about histograms? Well, what we need to work out and remember is this magic triangle. So frequency we're told, CW stands for class width. The main thing we need to work out is the frequency density, which is this vertical scale. So frequency density equals frequency divided by class width. A rather stupid way I've come to realise that this can be remembered is by thinking that FD could stand for fat dads, F feast, CW chicken wings. Fat dads feast on chicken wings. And there's a picture of some fried chicken just to help you. I know it's absolutely ridiculous, but you'd be surprised that sometimes ridiculous things are the most memorable. So FD, F and CW. So what we need to do here is an extra column for working out frequency density. So class widths just means the distance, the difference between the upper and lower bounds. So the first one, just 20 subtract 0, that's 20. This next one, 50 subtract 20, that's a class width of 30. 80 subtract 50, that's another class width of 30. 150 take 80 is 70. And finally 200 minus 150, that gives us 50. Now the frequency densities are just simply what we get when we divide this column by this one, the frequency divided by the class width. So the first one, 120 divided by 20, that frequency density gives us 6. 90 divided by 30, that gives us 3. 120 divided by 30, of course that's going to be 4. 140 divided by 70 is 2. And finally, 100 divided by 50 is, again, 2. So, like I've said here, this scale, the vertical scale, isn't given. This is where the frequency density comes into play. That is our vertical scale. The main thing is, keep the scale linear and make sure the highest value fits on to the graph. So it might be tempting to think, oh, each big square could be 1. But if that was so, 1, 2, 3, 4, not enough space. So what I'm suggesting is each little square, well, each 5 squares, sorry, could be equal to 1 unit of frequency density. So 1, 2, 3, 4, 5, 6. So here's my suggested scale. And that will work fine. The next thing is we just need to plot these, draw in these rectangles which represent the class widths. So the first one we need to draw is going to be from 0 to 20. So that's going to be here, if you notice. That's going to be 4 little squares wide. Each square along is worth 5 miles. And going up, we go up to 6. So it's 4 squares along, 6 squares high. So that's the first bar. The second bar goes from 20 to 50 and is going to have a height of 3. So the second bar needs to look like this. The third bar goes from 50 to 80, so from here to there, and has a height of 4, so it'll come up to that high. The fourth bar is going to be from 80 to 150, and it's going to be only 2 high, so quite a wide bar. Only 2 high. And the final bar, from 150 to 200, will have the same height, like so. So that's part A done. That's the histogram drawn. The next part is to estimate the median distance. Well, here we just need to remember what the median actually is. So the median is going to be the halfway value. So here, I just have to say goodbye to my chicken wings for a second. You've served your purpose. Bye-bye. Right, so the median is the halfway point. So if there's 570 students, just divide that by 2. So what's 570 divided by 2? If in doubt, calculate it. Should find it's 285. So therefore, the median is going to be the 285th person. So what I'm going to suggest we do here is we do a running total next to this frequency column. I'm going to call this CF for cumulative frequency. So we're going to stop when we get to the first one, the first total that goes beyond 285. So this first one is just 120. To work out the next one, we do 120 plus 90, which is 210. Then 210 plus 120 gives us 330. So that's more now than 285. So we now know for definite that the median is in this category. Okay, so 210 is where this second bar ends. So we need to go from 210 up to 285. So to go from 210 to 285, how many extra people is this? Well, let's do 285 minus 210. 285 minus 210, that gives us 75. And so it's 75 people after the point that this interval begins. So we can say it's the 75th one out of the total of 120 in the interval from 50 to 180. In other words, it's literally the 75th out of 120. So the median is somewhere in this third bar. So we can use this fraction to help us. So 75 out of 120. Let's work this out as a fraction. So 75 over 120. It's 5/8. It's going to be 5/8 the way along this bar. Okay, so this bar, this class interval, has a width of 30. Okay, so what we can do here is we can work out 75 1/20ths, which is 5/8 of this class width, which is 30. That's going to be 5/8 of 30 to you and me, because you know this simplifies to 5/8. So 5/8 of 30 18.75. So the median is going to be 18.75 the way into this bar. So we start at this bar here, and we're going to go, whoops, wrong arrow, we had an arrowhead here. So we're going to go just over halfway, 5/8 into it. So it's going to be plus 18.75. So therefore we can estimate our median. The median, this interval starts at 50, so it's 50 plus 18.75. These squiggly lines, by the way, means approximately equal to, just to emphasize it's an estimate. 50 plus 18.75, that's going to be 68.75. miles. Don't forget the units, we're talking distances. Median distance as an estimate, 68.75 miles. Question 18, we've got a bounds question. So high-speed train is travelling at a distance of 487 kilometres in 3 hours. Distance is given correct to the nearest kilometre, times measured correct to the nearest minute. So by considering bounds, what we need to do here is we need to work out the average speed in kilometres per minute of the train to a suitable degree of accuracy. And again, we must show all working and give a reason for our answer. Okay, I'm going to give some brief background on this in terms of upper and lower bounds. So I want you to imagine for a second, this isn't part of the question, this is just to help you make sense of what's happening. So imagine this scenario. Imagine you had 9 numbers. Okay, so I'm just going to type in some numbers here. The numbers, just 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so imagine these are your numbers. And you had to think about what the smallest fraction you could make would be. Okay, So you can only pick two numbers, one for your numerator, one for the denominator. You're allowed top-heavy fractions as well. So the smallest fraction, how would you make that? What two numbers would you pick to make the smallest fraction? Well, you get the smallest fraction, I'd bet anyone £1 to see if he can make a fraction smaller than 1/9. Whereas the biggest fraction, again, top-heavy fractions are allowed, that'd surely be 9/1. So what am I saying here? Well, what I'm saying here is to work out the smallest possible bound, the smallest value, you pick the smallest number for the top, biggest number for the bottom. To pick the biggest possible answer, you go for the largest numerator and the smallest denominator. So we're going to apply this logic here. So we want here to work out what the average speed of this train is to a suitable degree of accuracy. I'll mention this later. So speed is distance divided by time. Okay? So what we're going to work out here, first of all, is the lower bound for the speed. So speed min. So the minimum speed, using this logic here, it'd be when the top number is the smallest, so the smallest possible distance, that's going to be d min. The bottom number is the biggest, so the bottom number here is a time, so make the time a maximum. So how are we going to do this? Well, we need to think about what we're talking about, which I've sort of skipped past. Okay, distance, we want the units, by the way, to be measured in kilometres per minute. So let's just put this to one side and think about what the boundaries are. So the distance is 487. That's been rounded to the nearest kilometre. So what's the smallest distance it could have actually been before it was rounded to 487? Well, the smallest distance it could have been would have been 486.5. Anything less than 486.5, it would have rounded down to 486. So the lower bound for the distance is 486.5. Whereas the upper bound, think of this as the absolute limit of what it could be. So what's the limit in between the distance being rounded down to 487 to the boundary where it just round up to 488? Well, that boundary, again, would be a 0.5. It'd be 487.5. So let's now think about the time as well. Now the time is measured correct to the nearest minute. And just be careful here, we can save ourselves some legwork by looking at what we want our answer to be in. We want the average speed in kilometres per minute. So this here, I don't like to use the word a trick question, but we want to get away from talking about hours and talking about minutes. So 3 hours, there's 60 minutes in an hour. 60 times 3 hours, think of that as 180 minutes. Just makes it much easier if we do that. It's been rounded to the nearest minute. So what could that have been? What could the time have been before it was rounded to 180? What's the smallest amount of time we could have had? Well, it could be 179.5. 179 minutes and a half would just be enough to round up to 180. And at the other end, the border between rounding down to 180 and rounding up to 181 would have been 180.5. So these values are how we're going to solve this question. So returning now to this idea of what the smallest possible speed could have been. So we pick the minimum distance. So the minimum distance is 486.5 for our numerator. And the maximum time is actually going to be 180.5. Now, this can confuse people because people often think, well, if it were 180.5, wouldn't that have rounded to 181? Well, technically speaking, yes, but I want you to think of it like this. Okay, the time could have been 180.49, 180.49999. You could think of it as being 180.49 recurring, which technically is the same. You could be infinitely close to 180.5, so you may as well just call it 180.5. Remember, this here is literally a boundary. It's an upper absolute limit. It's not saying what the speed actually may have been. It's an absolute limit to what the speed could have been, given that these numbers were rounded. So, all we need to do now is to calculate this. So, 486.5 divided by 180.5. So let's work this out now. So 486.5 divided by 180.5 and give this to enough decimal places to be happy with. So I'm going to call this 2.69529. So 2.69529. Now what I'm going to do might confuse you, but this will make sense very shortly, I promise. So I'm just going to section off these numbers next, so we can compare in a moment with what we get with the maximum possible speed. Okay, so importantly, that's a decimal, so it's 2 point something. In fact, it's kilometers per minute. Next, let's think about the maximum possible speed we could calculate. Well, the biggest thing is when we pick the biggest possible value, which is going to be d max. And to make a fraction as big as possible, we divide it by the smallest thing possible. So we're going to pick to divide it by minimum value of time. So, maximum distance is 487.5. Whereas the minimum time is 179.5. So all we need to do next is just work this out on a calculator, see what we get, and give it to 5 decimal places. So, oops. So 487.5. Oops. Divide by 179.5. This equals, we now get 2.71588. So 2.71588. So what we next need to do is we need to work out the average speed to a suitable degree of accuracy. So what we do here is we go for the greatest number of significant figures to which both our answers, the min and max, both agree. So obviously we don't agree too much. They agree to one significant figure. To one significant figure, they both round to 3 kilometers per minute. To 2 significant figures, this would be 2.7. This would be 2.7 as well. That'd round down to 2.7. That'd round up to 2.7. Okay, if you went to 3 significant figures, this 2.69 would round up to 2.70, but to 3 significant figures, this one here, that 7.1 would round up to 7.2 because of that 5. That'd be 2.72. This would be 2.70. So to 3 significant figures, they don't agree. They only agree when given to 2 significant figures, or to 1 decimal place. So to 1 decimal place, they both round to the same. Any more decimal places, they don't agree. So we're going to go for 2 sig figs, or 1 decimal place. So from here, we can therefore say the speed is 2.7 kilometers per minute. So we pick what to round to by going for the maximum degree of accuracy to which both the minimum and maximum bound both agree. And that's only, in this case, 2 significant figures. Question 19. Simultaneous equations. This time we've got a quadratic one and a linear one, so this is going to be a bit tasty. So the only way we can do these is by substituting in a linear expression for either x or y into the quadratic one. So what I'm going to suggest here is we've got x plus 2y equals 1. We can fairly easily make x a subject here by subtracting 2y from both sides. So x equals 1 subtract 2y. Now what we do is we substitute this expression for x into the top equation. So therefore we're going to have 2 lots of x squared, which is 2 lots of 1 minus 2y squared, because that is what x is in terms of y. Then minus y squared equals 17. Next we need to expand these brackets. So we can have 2 lots. 1 squared is just 1. We then multiply the 1 and minus 2y together and double. So 1 times minus 2y is minus 2y. Double that gives us minus 4y. Then minus 2y squared, minus 2y times minus 2y gives a positive 4y squared. And of course minus y squared, that equals 17. So now we can expand these brackets out. So that expanded, whoops, actually I won't bother doing that. So we need to expand out this. So multiply everything here by 2. 2 times 1 is 2. 2 minus 4y minus 8y. 2 times 4y squared is 8y squared. Okay, so we have that. So next we can simplify slightly. So we have 2 minus 8y. Now 8y squared minus a y squared, that gives us only 7y squared. Now the next thing I'm going to do is I'm going to see if I can get this onto one side equaling 0. So if I subtract 17 from both sides, that will all equal 0. I'm going to neaten this up slightly, so then we'll have 7y squared minus an 8y, and then we're going to have 2 minus 15, and that will equal 0. Now at this stage it might be tempting to try and use the AC method or to see if this will factorise. You could do that, it's not a wrong strategy, but what I'd suggest would be if you've got a fairly hard quadratic and it's a calculator exam, which this one is, to use the quadratic formula. And so here we can work out what y is for two values of y by doing minus b so minus b, remember a, b, c. So I'll just colour code these so you can see. So that's our a, coefficient of y is minus 8, then minus 15. So it's going to be minus b, so minus 8, which is plus 8, plus or minus the square root of this number squared, so minus 8 squared, minus 4 times a, which is 7, times c, which is minus 15, and all that's going to be divided by 2 lots of a, never mind, 2 lots of a, which is 2 times 7. So let's just process this now. So we're going to have, oops, so 8, go for the minus root first, square root, minus 8 all squared, that's going to be 64, I can just do that, minus 4 multiplied by 7 multiplied by minus 15, and divide by 2 times 7, which is 14, we get minus 1, so y equals minus 1, or the second option is going to be when it's minus 8 plus this. So switch out with a plus sign, 15 over 7. So minus 1 or 15 over 7. So we've got two options for y. We now have two corresponding possibilities for x. So when y equals minus 1, we can work out what x is here. X equals 1 minus 2 lots of y. So we can use this expression to work out the corresponding value of x. So x will equal 1 minus 2 lots of minus 1. Minus 2 times minus 1 is positive 2. So 1 plus 2 gives us 3. Then when y equals 15 over 7, x will be 1 minus 2 lots of 15 over 7, which again we can fairly easily work out. So 1 minus 2 lots of 15 over 7 gives us minus 23 over 7. So just to neaten this answer up, our solutions are, we can have x equal to 3, y equals minus 1, that's one solution, pair, or we could have x equals minus 23 over 7 when y is 15 over 7. So two pairs of solutions, make them match up correctly, and we're done. So that's question 19 complete. Last but not least, the final question. So we've got some transformations to consider. So we've got triangle A, it's transformed by the combined transformation of first of all a rotation of 180 about the point minus 20, and then a translation with vector minus 3, 2. So one point on triangle A is invariant under the combined transformations. Find the coordinates of this point. So there's lots of information to unpick here. I'll unpick it step by step with you. The first thing though we need to do is a rotation of 180 degrees. So because we've got a rotation to do, I'm going to suggest that what the best idea may be is to actually trace out this shape. So if we trace triangle A, like so, then just read the rest of the question carefully. Well, the rotation is going to be about this point -2, 0, which is here. So let's just put this there and highlight it. So what we'll need here, I'd suggest, trace over the shape and then hold down with the compass needle at the point you're rotating it around. So I'd suggest get a compass needle, or you could use your pen, I suppose. Just put it over that point to hold it down, like this. But there's also other information as well. So it's about points on this triangle. One point on triangle A is invariant. So what on earth does that mean? Invariant means does not move. If something's invariant, it means it ends up in the same place as where it started. So my suggestion is going to be just to make a note of these 3 points on the triangle so we don't get confused or disorientated where each point's ended up. So just colour coding each point here for you. The top point I'm going to put as a green point, the bottom left in red, and the bottom right in this blue colour. So now I'm going to do the rotation, and it's 180 degrees, so it's half a turn. So this will end up being upside down when I'm done with it. So it's going to end up down here like so. So that's step 1 done, that's where it's rotated to. So it goes from here down to there. Get rid of the compass needle, we don't need that compass in the way anymore. Now the next thing is, it's translated by this vector -3, 2. The top number tells us how far to the right it goes. So because that top number is -3, that means actually we're going to go 3 units to the left. So we take it here, okay, and what we're going to do is we're going to move it 3 places to the left, like so. So it starts here, 1, 2, 3. So it's going to end up there. The next thing is, this bottom number is a 2, so that means it moves 2 up. So if we move this 2 up, it's going to go 1, 2. So if I just move it just away before I move up to it, that red has gone there, and the blue's switched as well. So it's like each point has moved. That green isn't the same as where it was, that red isn't the same, and the blue isn't the same either. So it's like each point's moved, but just think about this carefully. What about the point which is halfway in between this one and that one? What about this point if I do this in a purple? Okay, so that purple, which ends up here, okay, that would also, if I were to move it all, if I can, that would move up like so, and this purple would move up and touch it. So actually, it's that point there. It's the middle of the green and blue points. So when this triangle moves to the top, so it meets it again, albeit upside down, the point that hasn't moved is this one I've added in myself in purple. The midway point of the base ends up in the same location as where it started. So the coordinates of that point, it's -3.5 along, so it's -3.5, and it's 1 square up. And that's the coordinate of the point which doesn't move. So a tempting thing is for people to think like it must be like a whole number of squares. It must be like, you know, this clear square or that clear point. But actually this one here is in between these 2 points on the base. So it's -3.5 and 1. So that's a question 20 done, and therefore the whole paper's done. So I hope you found some of this useful. I don't expect you to have watched every single question. Do feel free to subscribe if you'd like. That'd be a very nice thing to do. And keep in touch for other updates and videos on GCSE. So thank you very much for listening and watching the video, and you'll hear from me very soon. Take care, and goodbye for now.